Sorry, do you need to write that down or can I go on? I can go on? Okay. 6 now. Part 1. Define capacitance. So what's the formula that has capacitance in it? Q equals CV. So what does C equal? Yeah, so we can say that capacitance is how much charge can be held per 1 volt potential difference. Yeah. So capacitance is the charge held per 1 volt potential difference. And what's the unit? It's the farad, isn't it? And the letter is capital F. And we will give the definition of the unit as well. 1 farad is 1 coulomb stored per 1 volt potential difference. And the key words you're looking at here: stored, charge per 1 volt potential difference. It's only 1 mark. So if you wrote that, I'd definitely give you the mark. Okay, can I go to the next part? So that was part 1. Part 2, you have a capacitor of 200 microfarads and a voltage of 75 volts max, and it's charged to 75 volts. How much energy? Oh well, come on, for babies. What's the energy here? A half CV squared. So, again, once you know how to use your calculator, a half times C times 75 squared.
Do we always have to make micro 10 to the minus 6?
It depends, it doesn't matter. There'll be a micro in your answer, but you have to just keep that in mind. If I put in the micro, it'll work out without a micro because the voltage is so large. So I get this many joules. Or some people might like to write this answer as 563 millijoules. Well, it's only 1 mark, so it can't be that much work. 4 identical capacitors is applied in series. How much energy is stored in the network? So 4 of these capacitors are put in series now. 1, 2, 3, 4. Right. Total capacitance would be 1 over 200 plus 1 over 200 plus 1 over 200 plus 1 over 200, which is 4 over 200. So C equals 200 over 4, which is 50 microfarads. Now what is the energy? The energy is a half CV squared. So type that in. A half times C times 75 squared, and this time we get 141 millijoules. I'm shocked that that is actually 3 marks. So shocked that I actually need to check the marking scheme to make sure I didn't do anything wrong. Seriously, like.
Too easy.
141?
Yep.
Alright. Okay. B part now. Oh, how much battery do I have left? Ooh, better finish this in a snap. Okay, B part. Right, there's a big resistor now of 2.8 kilo ohms and it's discharged, what is the time constant? Super easy. What's the formula for time constant?
2 pi.
No, time constant is RC. 2.8 kilo multiply 50 micro, and we get 2.8 times 10 power 3 times 50 times 10 power minus 6. The time constant is 0.14 ohms, farads. Sorry, isn't it RC? Yeah.
The C is for part 2, not 3.
Oh, thank you. It's not for, it's for which part?
Part 2,
So it's not 50, what is it?
200.
Thank you. 200 micro?
Yes.
Why do you have to include the 10 in the instead?
Which one?
Micro.
I'm putting in the micro if it's micro.
Why?
So you two. I'm not sure exactly what your question is. Because it's micro. If it's not micro, you're making it too big. Like if I said how tall are you, you know, if you said 150 or 150 centimeters, that's quite different. I need it. Anyways, what is this here? My battery's about to go. 2.8 times 10 power 3 times 200 times 10 power minus 6. 0.56. Right. If they wanted to know how long it would take to discharge, I don't think they ask it here, but if they wanted to know how long it takes to discharge, what do you do with this number? You multiply it by 5. So this would actually take 2.8 seconds to discharge fully. They could easily ask that. They didn't hear, I don't think. Sorry, I'm reading and doing this quickly, but I'm conscious that my battery's about to go.